Hello everyone, in this lab project we are going to make one half adder and full adder and first simulate the both in the multisim and then make it with TTL circuits. So before we start to making that, let's just see what is the half adder and the how half adder works. So the half adder is the unit. You could consider the half adder as a unit which has two input. You actually label that A and B. So which these unit able to add these two inputs, which is each of them is just one bit. So that means half adder has two input. Each input could be get one bit, which is one bit could be a 0 and 1, and add that two bits and give you a result. For example, if this is 0 and this is 1, 0 plus 1 should be 1, and you should see the 1 in the output. So definitely the biggest number you could give from each of these input is 1 and 1. So 1 plus 1 is 2. So how many bits do you need to represent the 2? Definitely answer is 2 bits. So for that reason, the half adder should be has actually two output too. So if we make one table for the half adder, we could say it has two input, A and B. It has two output. I label that C, this is S. Just be careful, S is the lowest value bits and C is the highest value. So you have two input. Definitely you could have four different case in your input. So these are the four different case that you have. So whenever the both is input, the both input is 0 and 0, you just should be give the result of 0 plus 0. So you have the 0 in the output. So whenever A is 0, B is 0, 0 plus 1 should be 1. So you should have 1, 0. So again, C, S is here lowest value bit. And the next is 1, 0, again 1 plus 0, the result should be 1. You should see this in the output, and whenever the both is 1, 1 plus 1 is 2, and you should have 0, 1 in the output, which is the 1, 0 in the binary is 2 in base 10. So 1 plus 1 is 2. That's what we have, C as a 1 and S 1. So C is the highest value bit. So this is half adder, and this is its table, which just shows how the half adder works and what should be the result. So what you have inside these half adder, these black box that I show here, so that's combination of the gate. So we will talk about how you could design the half adder in the course lecture. So we have a video for that in the digital playlist. So the half adder and full adder, I actually review both of them. So if you didn't watch that video, please watch that video first. So for the today's project, we just are going to making this with the gates. So then just verify this table and see if it works or not. We will simulate that first and then make that with the TTL circuits. So let's do what is the full adder. So you with using the 3/2 adder, you could make the full adder. If we be more general, we could say, okay, the full adder is the unit, is the box. So we should call that full adder FA. So it able to add 3 bits and give the result. So you could label ABC. ABC is just 1 bit. A could be 0, 1, B could be 0, 1, C could be 0, 1. So the question is how many output you should have for the full adder. So the biggest number you could give for A and B and C is 1 plus 1 plus 1. So the biggest number is 3 that you have in the output. So definitely with 2 bits you are able to show the 3. So that means you should just have 2 output. I label one S, which is the lowest value bit, and C as a highest value. So let's see its all possible condition that you could have in the input. So you have ABC, 3 inputs, each one could be 0, 1. So that means you could make actually 8 different bit pattern in the input. So I'm just list all 8 possible inputs that you could make. So which we actually check all of them. So let to just separate these 8 different inputs that you could have and see what should be the result in the output if you have the full adder. So this is C, this is S. So as I mentioned, this just able to add these 3 bits and give the result. So you have 3 0 in case number 1. So 0 plus 0 plus 0 is 0. You have 0 binary here. So 0 plus 0 plus 1 should be 1. So again, this is the lowest value bit. This is highest value. So that's a 1 is 0, 1. So 0 plus 1 plus 0 is 1. You should have this. 0 plus 1 plus 1 is 2. So you should have 1 0 in the output. 1 plus 0 is 1. You should have this in the output. 1 plus 0 plus 1 is 2. So you should have 2 in the output. 1 plus 1 is 2 plus 0 is 2. You should have this. And finally, whenever you have 1, 1. 1 plus 1 plus 1 is 3, so you should have 2, 1 as the output. So if you circuit work based off this table, you actually made one full adder. So again, what do you have inside these full adder? Inside this black box, I already explained in the full adder video in the digital playlist. If you didn't watch that, please watch that. So for this lab project, we are going to, with the gates, we are going to make one full adder, one half adder, and we first simulate them and to verify these 2 tables and make sure in simulation they are work, our circuit is right. And after simulation, we move to the TTL circuit and make these same circuit with TTL IC and also verify these table with the TTL ICs. So let's do first go to the simulation and simulate these circuits. So again, if you don't know what you have inside these black box and how you could design that, watch our full adder and half adder videos in the digital playlist. So I actually back here and I already simulate all of them. So this is the first one. This is a half adder. So inside that black box that I show you, so we have this circuit, which is combination of the XOR and AND. So I already in that video, in the half adder video, I explained how you could end up with this circuit and how you could design that. For the lab project, so we already know how we could design the half adder, and we have inside that box, which is this black box I show you as a half adder, we actually put these our design that we already explained. So this is your 2 inputs for your half adder. So you could give 0, 1, which is changing this switch here. So and you have to you connect the output to the LEDs. So if they are turn on, the LED means the output is 1. This, if the LED is off, it means 0. So let's start to verify this. So I need to, probably one of my simulation is on. I need to turn that off first, then I back to here. So this is half adder. Let's test that. So if I start with the 0, 0, 0, I start the simulation. So as you could see right now, I have 0, 0 in the input. So 0 plus 0 should be give you 0. So 0, 0, which is off. If I say right now I have 1 plus 0, so it is 1. Just be careful. This is the lowest value and this is the highest value bit. So that means 1 plus 0 is 1. So let's switch between this. Say 0 plus 1 again is 1. How about 1 plus 1? So right now this is 1. I change that to the 1. So 1 plus 1 is 2, which is 1, 0. This is again the highest value bit. 1, 0 is 2, right? So I test all of them. So see, 0 plus 0 is 0. So 0 plus 1 is 1. Again, 0 plus 1 is 1. And 1 plus 1 is 2, which is 1, 0. So it works. You simulate that. And as a next step, we will actually implement these circuit with the TTL IC and again do test the same thing and make sure the circuit that we made actually is the half adder. So let's check the full adder. So let's zoom this a little bit, that's able to see better. So And also I could close this. So as you could see here, so first I need to stop these half adder. So back here to the full adder. So as you could see here for the full adder, I already explained in the full adder video in the digital playlist how you could actually make this full adder and why this circuit is full adder. So for now, you consider this is the black box that I show you in the beginning of this video. So you have three inputs to this full adder and you have two output. These two your output and this 1, 2, 3 is your inputs. And whatever you have between is that black box that I show you in the beginning of this lecture. So even if you back to what I explained, so here is the same thing. You have three inputs and two outputs. So I want to verify this table that I have with the simulation. So I made the circuit. So let's start to simulate that. So I close this. So it should be at these 2 bits, right? Let's start with the first one, which is 3, 0. So again, whenever you turn on and off this switch, whenever switch is here, it gives you a 0 to this input. Whenever this is here, it's connect to the VCC if you have 1. It's the same for all these 3. So these 3 is your input, these 2 is your output. So whenever these output, these LED is on, means you have 1 in the output. Whenever this is off, means you have 0. So see, now you have 0, 0, and 0. So 0 plus 0 plus 0 should be 0. So, but that's the reason the both is off. That's right. So add just 1. So 1 plus 0 should be 1. So again, this is lowest value bit. This is the highest value. So if you add 1 more, so 1 plus 1 is 2. This is 1, 0, which is 2. Again, this is highest value. This is the lowest value. 1, 0 is 2, which is works. So if I add 1 more, should be 3. I have 1 plus 1 plus 1, so you have 3. That's the reason the all is on. So if you test the all value that you could make, so you will see they actually works and you could actually verify the all different condition that you could have here for input, which is I test more of them. So I could say again, I put 0, this, 0 to this, 0 plus 1 is 1, you have 1. If you, for example, add one of them, should be 2, which is right. If you add again another one, which is 0, 1, plus 1, again, it is 2, right? So as you could see, this circuit works and you simulate one full adder. So let's check the TTL circuit and make both these half adder and full adder circuits with the TTL IC and see the circuit works or not. So after simulation, let's implement the circuits with the ICs and the digital gates and see the circuits works or not. So here we implement both circuit. So this section we implement the half adder. In this section we implement the full adder. So let's start with the half adder. So we use these two switch for the input A and B for our half adder, and we use these two LED as a output of the half adder. So this LED here is the highest value, this is the lowest value. So let's start to check all 4 different cases that we could give, or 4 different bit pattern that you could give to the input of the half adder. So as I mentioned, this is A, this is B. Right now the both is 0, so the output is 2, 0. So 0 plus 0 is 0, and that one is right. So the next could be 0, 1. So the A is 0 and B is 1. I change B to the 1. A is 0, B is 1. 0 plus 1 should be 1. So as you could see, lowest value bit is on and the highest value is 0, which means you have a binary 1, which is works. So next we put A as a 1 and B as a 0. A1, B0. 1 plus 0 again is 1. Highest value bit is 0. Lowest value bit is on, which means we have 0, 1, which is 1. So that works. So the last case sheet, both is 1. A is 1. I turned the B is 1. A 1, B 1. So 1 plus 1 is 2. As you could see here, highest value bit is 1 and the lowest value is 0. So we have 1 0, which is 1 0 is 2 in decimal. So as you could see, it is works. You could actually test that very fast. So 0 0 is 0. If you add A is 1 again, you have 1, or B is 1, you have 1. Whenever both is 1, you have actually 2, because 1 plus 1 is 2. So let's check our full adder. So we put the input of the full adder to these 3 switch that we have here, A, B, C, these 3 switch. And the LEDs is here. So here we have the highest value bit, and this is the lowest value bit that we have. So let's start. This is A, this is B, this is C. So first, all A, B, and C is 0. So that means you have 0 plus 0. So the both output is 0, which you see here. So the next, I actually give A0, B0, and just change C to 1. So that means I have 0, 0, 1. So the result should be 1. So as you could see, the lowest value bit is on and the highest value is 0, which means we have 1. So then I actually just give 0, 1, and 0. A0, B1, and C again 0. So again, we have 0, 1 plus 0 is 1. So the lowest value bit is on, highest value bit is 0, which means I have 1 in the output. So the next could I have is 0. I keep A0, and the B and the C both will be 1. So A0, B, and C is 1. So that means I have 0 plus 1 plus 1 means I have 2. So as you could see here, the highest value bit is on and the lowest value is 0. So I have 1, 0, which is 2. It's right. So next, I give A1 and B and C 0. So A1, B, and C is 0. So that means I should have 1 plus 0 plus 0, which is 1 plus 0 plus 0 is 1. So as you could see on the output, the lowest value is on, highest value is 0. So 0, 1 is 1. So the next possible is I keep A and C 1 and B 0. So C A1, B 0, and C 1. So that means I have 1 plus 0 plus 1. I should have 2. So as you could see, the highest value bit is on and the lowest value is 0. So that means I have 1, 0, which is 2, which is right. So the next, I put A and B to 1 and change the C to the 0. So A1, B1, and C is 0. So that means I have 1 plus 1 plus 0, so it should be 2. So as you could see here, the highest value bit is on and the lowest value is 0. So that means I have 1, 0, which is 2. And finally, I actually going to give 3, 1. So 3, 1. So as you could see, you have A is 1, B is 1, and the C is 1. So you see we have 3, right? The highest value and lowest value both is 1. 1, 1 is 3 in base 2. So as you could see, for all 8 inputs that you could provide to your full adder, for all of them, this is works. So we could actually try some. We actually did that. So as you could see, all of them works. Here I just show that few of them again. So 3, 0 is 0. So C 3, 1 is 3. That's right. So whenever you have 3, if you have just 1, 1, it's give you a 1. So here I give B1, it is again 1. Here I give C1 again is 1. So whenever I add 1 more 1, it's changed to the 2, which is the highest value. And whenever I have all 3 on, it give you a 3, which is 1, 1. So as you could see, I actually test for all 8 different bit pattern that you could give as an input, and for all of them it works. So thank you for watching this video, and I hope you liked it.